So welcome everyone. Now this problem which we are discussing in this particular video is named as leap year basic in the basic arrays category. For an input in year n, input year means input integer because it is given in the form of integer only. Years are in integers. Input integer n will be given and we have to check whether the year is leap year or not. So input will be an integer, output will be true if it is a leap year, otherwise false if it is not a leap year. So output will be a boolean or a bool kind of value, that is either true or false will be the output. So example is, if 1600 is the input, year is equal to 1600, then is 1600 a leap year? Answer is true, yes it is. Explanation is 1600 is a leap year. What about 1800? 1800 is not a leap year, and explanation is 1800 is not a leap year. So there is not much of an explanation, to be honest. Why? Because it is pretty standard that which kind of years are leap years. If you know it, then you know it. If you do not know it, then like you have to cram it, the definition of a leap year. So constraints can be the input, the year can be anything from 1, that is 0001, 3 zeros and 1, and then up till 9999. So it will be a 4-digit year at max. And what we have to do is we have to return true or false depending on whether it is a leap year or not. So let's now think of the approach what we can use to solve this problem. See, a pretty standard definition of which year is a leap year or which year is not a leap year is, leap year repeat every 4 years. Every 4 years you will have a leap year. A leap year is such a year where you will be having 365 days, no, 366 days in a year. Usually every time we have 365 days, that is February month have 28 days. But what happens in leap year is February month will have 29 days in most of the calendars. Like at least in terms of the Georgian calendar, it will be 366 days. So this property of leap year repeats itself after every 4 years. That is, every 4th year is nothing but a leap year. So how I can check whether a year is a leap year? We can surely check whether it is a leap year or not by checking whether it is a multiple of 4 or not. Whether a year will be multiple of 4, then it will be a leap year. Example can be, you can say 2004, 2008, 2012, 2016, 2020. Next leap year will be most probably like when you will be watching this video. So next leap year which you will face will be on 2024. So these are all the leap years which you can see, which will repeat themselves after every 4 years. So what is the common property among all of them? One of the common property among all of them are, they are multiples of 4. How I can check whether a number, whether an integer is a multiple of 4? We can check by dividing by 4 only. If the number is properly divisible by 4, or you can say 4 is properly able to divide the number, then it is a multiple. So how can I check whether this number is properly divisible by 4 or not? We can use the modulus property, which will give me the remainder. So 2004 modulus 4, what will be the answer? On dividing 2004 by 4, the remainder will be 0. Same goes for 2008, same goes for 2012, same goes for 2016. All of these years, when divided by 4, they will let the remainder remain 0. They will properly divide the numbers. So we can surely check whether a number is multiple of 4. But there are certain corner cases. What are the corner cases? The corner cases are, if a number is a century number, if a year is a century year, example, the years ending with 00, that is 2000, 3000, 4000, or you can say 3200, these kind of years which are ending with 00, these kind of years are usually not leap years. These kind of years are usually not leap years. But one more condition is, if those years are multiples of 400, then they will be leap year. If these kind of century years, if they are multiples of 4, they will be leap year again. So two scenarios when a year can be a leap year: if it is a multiple of 4, but it is not a multiple of the century, it is not a century. So how can I check whether a number is century? We can surely check by dividing by 100, because if we will divide by 100, then it will give me the last 2 digits as the remainder. That is 2004 modulus 100. What will be the answer? On dividing this number by 100, the answer will be 4, last 2 digits. If I will divide 2000 by 100, the remainder will be 00, last 2 digits I will get. So if last 2 digits are 00, then it is a century year. So how to check whether a year is century? If modulus 4 will be 0. But if a modulus 4 is 400 is equal to 0, then such a century year will still be a leap year. So examples can be, if I take 2000, so 2000 modulus 400, what is the answer? Is 2000 a multiple of 400? Yes, surely it is. So since it is giving me 0, yes, it is a leap year. 2000 is a leap year. What will happen for 3000? 3000 modulus 4 400. Is it 3000 modulus 400 0? No, actually 3000 does not comes in the table of 400. But is 3000 modulus 100 0? Yes, it comes in the century. 3000 is a century year ending with two zeros. But it is not a every 400th century, or you can say every century which is occurring after four intervals. So 2000, even though it is a century, it is a leap year, but 3000, it is a century, it is not a leap year. So finally, there are three scenarios when a number will be a multiple of 400. First scenario. Second, if it is not a multiple of 400, then if it is a multiple of 100. If not, then if it is a multiple of 4. So we will be starting from bottom up. That is, first we will be checking for 400 divisibility, then 100 divisibility, then you can say 4 divisibility. So if I just show you the logic, we can say if the number, if the year modulus 400, if it is equal to 0, then what we can say? It is a multiple of 400, then surely it is a leap year according to the question itself, according to the definition of leap year, 2000 is a leap year. First scenario. Second, if it is not a multiple of 400, then we have to check for century. Because if a number is a century, is it a leap year or is it not a leap year? It is not a leap year. So return false. In this case, we have to return true. In this case, we have to return false. And third scenario will be, if the number we can say is year modulus 4 equal to 0, then again it is a leap year. Then again it is a leap year. And if number is none of them, then if number is none of them, then again number is not a leap year. So it is getting alternate, kind of it is alternate. If year modulus 4 is not 0, then forget about all of this, because if number is not a multiple of 4, how can it be a multiple of 100? How can it be a multiple of 400? So if number is not a multiple of 4, it will surely again will not be a leap year again. That is, examples can be year 2023, 2022, 2021. All these years are not leap years. Like you will not have 366 days. You will only have 365 days. But in this case, like example 2004, 2008, and so on, yes, they are. What about this? 3000 is not a leap year. What about this? 2000 is a leap year. So I hope now everyone is clear with which year is a leap year and how to check which year is leap year. How you can actually solve this? See, since we are having four conditions, first condition, if not true, then check the second. If it is not true, check for the third. If it is not true, check for the fourth. So we will be requiring if else ladder. So it is a syntax which is using if else if ladder. In different programming languages, you have to use different syntax. Example, Python will be using if elif, Java will be using if else if. Similarly, C++ will also be using if else if. So depending on whichever language you will be coding in, you have to use that particular language syntax. Or you can also use a switch case. You can also actually use the nested if else if you want. That is, first check for divisibility by 4, then check for divisibility by 100, and so on. So that you can also do, but this will be the easiest approach, using the ladder, using if else if else if else. So now we are done with the second milestone, that is finalizing the approach using conditional statement, using if else statement. Now we will be coming up to the instruction manual in the third milestone. So first, check if the number, the year, is a multiple of 400 or not. That is, if it is a century which is occurring after every 4 years. How we can check? Whether modulus 400 will give 0 or not. If the number modulus 400 will give me 0, if n modulus 400 is giving me 0, then it is a multiple of 400. If yes, then is the number leap year? Yes, surely. So return true. Else, if it is not a multiple of 4, then check if it is a multiple of 100. That is, it is a century year. If a number is a century year, but not a multiple of 400, not a century occurring after every four times, that is every fourth century. If it is not that one, then it is not a leap year. Return false. Third case, if the number is a multiple of 4, that is, it is a year occurring after every 4 years, then surely again it is a leap year. So again return true. And if it is none of them, if it is not a multiple of 4, even not a multiple of 4, then what we can say? Then finally else we can say return false. That number is not a leap year is not a leap year. 2003, 2005, 2007, all of these years are not leap years. We are now discussing the code of this problem in Java programming language. So for that, first of all, we have to check if the number is a multiple of 400 or not by doing n modulus 400. If there is a year which is a every century occurring after every four intervals, or you can say every fourth century, then every fourth century will be a leap year. Example can be 2000, example can be 4000, example can be 6000, 8000. These kind of centuries are actually the leap year. So if I just return something in the last, if I just return false in the last, let's run this code for the sample test case where I am like providing 2000 as the year. So for 2000, it should actually give me true. Let's see if it is giving me true or not. So it is giving me true. Yes. Now let's check for the second type of year. If it is not a every fourth century, then if it is any other century, that is first or second or third one, that is, it is not a multiple of 400, but it is a multiple of 100 at least. It is a century, but not every fourth one. Then what is the answer? Then answer is false. Example can be 3000. Example can be 3000. Let's try for 3000. So is 3000 going to be a such a leap year with such a year which is leap? Actually, output we are getting, we are saying return false, but we are not returning anything after the else if. So we should return something. The code is expecting us to return something. So let's return false, because if you are not returning anything after if else, then you are actually not fulfilling the return type criteria. So for now, 3000 answer should be false. Yes, we are getting false. Now, third scenario is if a number is not a century, but if it is a multiple of 4, else if n modulus 4 is 0. If it is a multiple of 4, then it is a year occurring after every 4 years. Then here again it is a leap year. So return true. Example can be 2004, 2008. So let's try for 2012, or actually, yeah, 2012. It should be giving me a leap year. And again, my code should return something in the last. So I will be returning false in the last. Let's see for 2012. If it is giving me true, then the output we are getting is correct. Otherwise not. So 2012 is correct. What will happen for 2013? See, if it is not true for the century, for the 400th century, that is every fourth century, if it is not a multiple of 4 also, then surely it is a number which is the last case. It will get handled in the line number 29. In that case, it will be giving me return false. That is, it is not a leap year. So 2013 should give me false. Let's see. So it is running. Let's wait for it. And yes, it is getting accepted. So let's submit also for all the test cases. So all the test cases are working. What is the time complexity? What is the space complexity of this code? We can surely say that since there is a simple if-else if condition, the time complexity is also going to be constant. The space complexity is also going to be constant. Both will be taking some constant amount of time only. So with that, we have discussed the problem leap year basic. We will be meeting in the next video where we will discuss some more problems. Till then, bye bye. Take care.